Right, hi everyone. Another video. This one on double angle formula. Okay, what are they and how they're made? So this won't be as long as the other one. This will complement the compound angle and addition formula one because that's where they come from. So what do we mean by double angle formula? What I mean is sine 2x, cos 2x, and tan 2x. And by default, I'll be able to know what sec 2 is and sec 2x and cosec 2x and obviously cot 2x as well. Okay, but how do we come up with this sine 2x, cos 2x, tan 2x? These are extremely useful formulas, especially when you're doing integration. So we are going to put some integral problems in here. Okay. So sine 2x, where do I get that from? Well, it all comes from the addition formula. So sine A plus B, as we know, is sine A cos B plus cos A sine B. So can we see that sine 2x, if we let x be A and also let b be x, so let A and B both be x in here, so x plus x, can you see we're going to get sine 2x? So if all of these a's and b's are x's, we're saying then that sine x plus x becomes sine x cos x plus cos x sine x. So can you see we've got two lots, so we're saying then that sine 2x is the same as two lots of sine x cos x, okay? And again, these formulas just need to be so tight. Like you just need to be able to whip them off of your brain onto the paper, onto the page, because it's just kind of like standard that you know them, right? So same for cos 2x. Now for cos 2x there are three versions, but again it all comes, as long as you know one, then you know all the others. So cos A cos B from our addition formula minus sine A sine B. Okay. So if we do the same, let x be x, let x be a and let x be b, so we get cos x plus x, so we get cos x, because it's cos. We've got a plus in the bracket, so we need a minus, sine x. So we've got cos squared x, take away sine squared x. And this is our cos 2x on the left-hand side. Now, that's version 1, but like I said, there is actually three versions of this. So 1, 2, 3. So we got cos 2x. So I think in class I said you're going to have 5 more added. And here are your 5. So tan 2x, right? So cos 2x we know is cos squared x take sine squared x. So kind of similar to cos squared x plus sine squared x, isn't it? Just change it to a minus because you know cos squared plus sine squared is 1. Okay, and that's how we're going to find the other versions, because if we change cos squared x to 1 take sine squared x, then we get our second version, which is 1 take 2 sine squared x. So 1 take 2 sine squared x. And likewise, if we replace sine squared x with 1 minus cos squared, so you see what I mean? Like you can just derive this stuff from scratch, but you don't want to be wasting time doing that. You want to, know your stuff, know your formulas, so you don't have to waste time doing this. So cos squared plus cos squared is 2 cos squared, but of course it's fun to actually do this. But I just wouldn't want to do this in my exam or something. Okay, so there we go. There's the third version. And then finally, we've got our tan 2x as well. Okay, so linking again to the addition formula, tan A plus B, remember it's tan A, same sign on the top, tan B, 1 minus tan A times tan B. Okay, so again, let A be x, let B be x, and therefore tan x plus x is the same as tan x on the top plus tan x on the top, 1 minus tan x times by tan x. So on the top we get 2 tan x, and on the bottom 1 minus tan squared x. Okay, 2 tan x, 1 minus tan squared x. Alright, just like with the compound angle formulas then, see what you can do. See if you can memorize them. Okay, so what is sine 2x? What is cos 2x? All three versions. These are such handy formulas, and you really do need to have them memorized, have them in your arsenal, and do it early. That's one mistake people make. I mean, over time, you just kind of see, what are you doing? What are you doing? You don't know your formula. How are you meant to do anything if you don't know any formula? And then, when it comes to exams, like, yeah, I'll learn it later. And then you realize, hang on a minute, I've got like 30 formulas to learn here. Just learn it early. Get on with it, Okay, ran over. So there's two starred ones here because we're going to add to that in a second, right? So I want you to write down these from memory, write them out a few times, put in the effort early, and it will pay off, okay? It'll make you way more fluid with the maths. Okay, now, why are these useful? Well, there's a pretty cool exercise that you can do here, because imagine if we had that cos squared 3x minus sine squared 3x and we wanted to solve when it was like a half or something. Do you see? That's going to be really hard. I don't really know. Actually, it's not going to be really hard, is it? You could just change that to 1 minus cos squared, which you could therefore do something with. But let's pretend I didn't make a question which was really easy. Let's pretend that we can't do that, right? So our objective is just to write in its simplest form. This is just a good exercise. So ignore the fact that I picked a shitty example, and let's just, sorry, didn't mean to swear. Apologize. A bad example, and let's just treat it for a good exercise, right? So cos squared 3x takes sine squared 3x. The idea of this is to recognize, well, what is that? That looks exactly like cos 2x, doesn't it? Okay, now this is an important thing to recognize here. Cos 2x is the same as cos squared x take sine squared x, isn't it? But go back to where this came from, because cos 4x, I'm going to say, is exactly the same as cos squared 2x take sine squared 2x, right? And because think about where these things are made from. Cos 4x is the same as cos 2x plus 2x, isn't it? So that's cos 2x minus sine 2x, which is going to be cos squared 2x take sine squared 2x. Do you see? This is why it's also called the half angle formula, right? Because that angle there is always halved here. So you could call it double angle depending on your perspective, or half angle depending on your perspective, okay? So I could write sine x as 2 sine x over 2 cos x by 2. Do you see? The angle is halved. I could write tan 7x as 2 tan 7 over 2x over 1 minus tan squared 7 over 2x. Do you see? That angle in there is always halved. So this example now should be pretty self-explanatory. Cos squared 3x minus sine squared 3x, well, that must be cos 6x. Do you see? And why is that so? Because cos 6x is made up of cos 3x plus 3x, which links to our addition rule formula. Okay, so don't get too stuck on cos 2x and sine 2x and tan 2x. It can be anything. Okay, let's look at this one. What can that be simplified down into a single trigonometric function? Well, hopefully you're saying that looks a lot like sine 2x, right? Except the angles aren't x's, they're 2x's. So what happens? That's right, say it nice and loud. we have to change our angle. We have to double the angle, right? Because it's half the angle here. So it looks very much like sine 4x, except it's got a 6 on the outside. So therefore, we just need to times it by 3. Again, one of the common mistakes is, so 3 sine 4x, 3 sine 4x. Common mistakes is that people see 6 in here, and then for some reason they like times the angle by 6, or something like that. Something it doesn't make any sense. If you understand where they come from, right? So just 2 sine 2x cos 2x comes from sine 2x plus 2x in your addition formula. Sine 2x cos 2x plus cos 2x sine 2x, okay? So it makes no sense to not have a 2 in the front. I hope they've made that clear. Alright, now this one here underneath, this looks pretty hideous, doesn't it? Now, what I like to say is, whenever you see a sine and cos together with the same angle, so I can see a sine and cos together with the same angle times by each other, I'm immediately thinking sine 2x, instantly. So this looks a lot like sine 2x, because sine 2x is 2 sine x cos x. Ah, and it's almost got the 2 as well, hasn't it? It's got a 4 here. So this looks like 2 lots of 2 sine x cos x, all times by cos 2x. And we know that 2 sine x cos x is sine 2x. So I'm just going to write this up here. So the 2 stays on the outside. 2 sine x cos x becomes sine 2x. And we've got a cos 2x as well. Can that be simplified down further? Yes, because the same rule applies. I've got a sine and a cos with the same angle. So 2 sine 2x cos 2x, it looks exactly like sine 4x. Okay? I hope that's made sense. So actually the top and bottom, number 2 and number 3 are virtually the same, just with a different multiple on the front. Now, I am going a bit ahead here. I'm going quite ahead of where you're at the moment, but I just really want to emphasize some stuff. So we can't integrate sine squared or cos squared. You can't do it, because what you're trying to do is, when you integrate, as you know, it's the opposite of differentiation, right? So if sine x differentiates to cos, if I integrate cos, I go back to sine, don't I? Plus c. I get sine x plus c. Do you see? Let's see. Right. And we know that cos x differentiates to minus sine x. So if I integrated minus sine x, I would get cos x. If I integrate minus sine x, so if I integrate sine x, sorry, I would get minus cos x, because remember, when we differentiate, we work left to right. When we integrate, we work right to left. So if I integrate minus sine x, I'm going to get back to cos x plus c. But if I integrate sine x, notice that constants are interchangeable. So if I multiply this right-hand side by minus 1, that's going to go. But if I do that to the left, right, I've got to do it to the left. So minus cos x. Do you see? So basically, minus cos x differentiates to sine x. So therefore, sine x integrates to minus cos x. Right? So sine x goes back to minus cos x plus c. All right? Now, all of our integration then, our C4 work, again, I'm talking C4, so I'm going forward, sorry, by quite a way. All of our C4 integration work relies on this table, relies on us knowing this table intimately, okay? Now, if I list all of our differentials which we know, and which we've proved in class now, we know e to the x goes to e to the x, we know cot x goes to minus cosec squared x, we know cosec x because it begins with a co, goes to minus cosec x cot x. We know that ln x differentiates to 1 over x, okay, etc., etc. Sine squared, there's nothing to do with sine squared on this right-hand side. So we can't integrate it. But we can. Of course we can, because we've got our double angle formula, okay? So we know, I'll be quick for this, we know that cos 2x is the same as 1 minus 2 sine squared x. That's one version of cos 2x. Notice if we rearrange and make sine squared the subject, so if I move the sine squared over and move the cos over here, so I get 2 sine squared x is 1 take cos 2x, and then if I divide by 2, I get sine squared x is a half take half cos 2x. Now this is fundamental formula then. This is the one to go back to, so if you scroll back, to add here to your stars. So sine squared x is the same as half minus half cos 2x, okay? And we can do the same for cos squared. So we know that cos 2x is also 2 cos squared x take 1. So if we rearrange this to make cos squared the subject, so if I move the 1 over and then divide by 2, we get cos squared x is a half plus a half cos 2x, you see? Really easy to remember if you know one of them. So sine goes to half minus half, cos goes to half plus half cos 2x in both, okay? So we'll update our other one here. So cos squared x is the same as half plus half cos 2x. Alright? Some new formulas. So I won't go too far integrating this, but basically if we're integrating sine squared, we can change that to half minus half cos 2x, and cos is absolutely on our differentiation table. Not cos squared, just regular cos. So the half we know goes to half x. This minus a half can stay, and cos 2x. Do we go into this now? If we differentiated cos 2x, we get minus 2 sine 2x. But we're integrating it. So you're going to get sine 2x, and this 2 would pop out if we differentiated, but we're doing the opposite. So we need to do divide by 2 rather than times by 2, and we're going to need a sorry, and the minus is going to have to stay. Plus c. Now if you differentiate that to check, you'll see that this works. Okay, this is called reverse chain rule. You will do that a bit later. Now cos squared 4x again looks horrible, but we know an identity now. Except we haven't got cos squared x, we've got cos squared 4x. So just like before, you can manipulate all of these formulas. So here, I've got cos squared x, but if I put a 4 in there, then this 2x also needs to be times by 4. So this becomes 8x. So I get half plus half cos 8x dx, right? So therefore, the half goes to half x. That half here stays. Cos goes to sine 8x. And if you differentiated it, the 8 would come out. So we need to divide by 8 to compensate. So we get 16. Right, we will do more on this integration stuff later. But there we go. Video done. I think that's long enough.